Hi, everybody. I'm super excited to be here today, and it's just to give an introduction to Apache Airflow. I'll be focusing on how you can use Airflow to create flexible, scalable, and powerful data pipelines, all using Python. So to start, before I dive in with a bit of background about myself, I'm a lead developer advocate at Astronomer. My background has been a bit varied. I've worked as a data engineering consultant. I started at Astronomer as a field engineer before moving on to this developer advocate role. I learned Python when I was in grad school doing data science work. But this progression has been really totally driven by Airflow. Airflow has played a really big part in all of these roles that I've worked on. And so I'm really passionate about it and really excited to share more about it today. And so I want to talk today about why Airflow is such a great tool, and I'm going to cover what it is and generally why writing data pipelines in Python is a good thing. For some background, I'll cover Airflow core concepts and terminology so you sort of know what the ecosystem looks like and how everything fits together. And then I'll dive into some key use cases. And finally, I'll share the easiest way to get started with Airflow if you want to use it yourself. So let's start with what is Airflow. Simply put, it's a tool for programmatically authoring, scheduling, and monitoring your data pipelines. It was originally created at Airbnb. It's since been open sourced and is now a top-level Apache Software Foundation project. It's widely considered the industry's leading workflow orchestration tool, namely because of major benefits like core functionality built in Python that makes it highly extensible and scalable. It also has a large, vibrant open source community. And I'll note that Astronomer, I work as the commercial developer of the open source project. So at Astronomer, we're obviously heavily invested in Airflow. And we do, again, believe that it's sort of industry leading. So diving a little bit deeper, the core tenets of Airflow are what make it a world-class orchestrator. And many of them stem from the principle of pipelines as Python code. There are obvious benefits of having your data pipelines written in code, namely that you can treat them as you would any other piece of software. You can put them in version control, you can use CI/CD for managing deployments, stuff like that, which I'll note is a departure from many legacy data pipelining tools that often had a more drag and drop kind of GUI experience. So pipelines as code was a big deal when tools like this were created. And in addition to that, Airflow's framework brings other benefits like a flexible, extensible platform. So anything you can write in Python, you can implement in Airflow, which you can imagine is super powerful. It's also designed to be scalable, secure, and pluggable with your external tools, meaning you can productionize it even in large organizations. So next, I'm going to go through some of the Airflow core concepts and terminology. Again, this is background that's helpful when you're getting started with Airflow because these are the sort of pieces that you'll be working with. So it's helpful to know what they are. And I'll start with the Airflow core components. So these are the infrastructure pieces that are required to make Airflow run. If you are, working with data pipelines and writing the Python used to run them, you're not likely to interact with these pieces as much. These should be sort of under the hood, but as we'll see a little bit later, it is important to know what they are. So the first three kind of core components are your web server, your scheduler, and your database. So your web server serves your UI that you interact with. Your scheduler is the process actually responsible for scheduling the jobs, which is obviously important for an orchestrator. And your database is going to be your metadata database where you store all of the metadata associated with your tasks. You also have an executor, which will define how the tasks get executed. You have multiple options for what this looks like. That's sort of out of scope for this talk, but again, good to know that that's something that is running in background. And if you were going to use this in production, you would want to look into that. You also have a couple of other pieces that you may have depending on your Airflow setup. So you might have standing workers for processes that are going to execute all of your tasks. You might also have a trigger if you're going to run deferrable operators, which again, out of scope for this talk, but good to know that these things kind of exist. So now diving into the core concepts, which is going to be more what you'll interact with kind of as a pipeline author or somebody writing the Python for data pipelines. And the most core concept, or the highest level core concept, I should say, within Airflow is your DAG. A DAG is your data pipeline. It stands for Directed Acyclic Graph. You can think of each node in that graph as a task and each edge as a dependency between tasks. And the only rules for a DAG are that your tasks flow in one direction and have no loops. So hence the directed acyclic part. Having a loop between tasks, something like this invalid example on the right, could create an infinite loop in your code, which you obviously want to avoid. But other than that, anything that you can define in Python, you can do in your Airflow DAG. Diving in a level deeper, you have tasks. So again, a task is a node in your DAG. You can think of it as kind of like a single unit of work. So best practice is to keep tasks atomic. And then when you actually run your DAG, so run your data pipeline, you'll have a task instance. So that represents a specific run of that task. So for a DAG, for a task, for a point in time, that's a task instance. You'll see that sometimes as TI, like in code, that's what that's referring to. And a task can do, again, really whatever you want it to do. It might make an API call, it might kick off a Databricks job, it might run a Python function, it might wait for a file to land in S3. We'll talk more about kind of what you can do with tasks, but again, you have a ton of flexibility there. And kind of building on that, what does a task actually do? Another core concept is an operator. So operators are like the building blocks of Airflow. You can think of them as a wrapper around each task that defines what that task is going to do. And generally, these are great in that they limit the amount of code that you'll have to write yourself. And we'll show some practical examples of this. But just as some examples, there are tons of operators in the Airflow ecosystem. Some of them are pretty obvious in what they do and are built within the core of Airflow. So like the Python operator will execute a Python function. The HTTP operator will make an API call. You do have a class of operators called sensors, which will wait for something to happen. Those are a way to make your DAGs more event-driven. So like the external task sensor will wait for another task to complete before starting. And then you're going to have operators that are much more specific to particular use cases or interacting with third-party systems. So Snowflake has a set of operators used to interact with Snowflake. So does Databricks, your major cloud providers, like I've shown here. So these are just a couple of examples to give you a sense, but the ecosystem is really big. That kind of leads me to the next core concept, which is of providers. So providers are separate Python packages. So again, separate to the core of Airflow, I should say. So you would install them separately from your Airflow instance using, pip install or something like that. These are all on PyPy. And they're going to contain all relevant modules for a third-party service. So operators, sensors, things like that. So again, these might be for major cloud providers like Google, Amazon, Azure. They may be for external tools like Snowflake or Databricks or Apache Beam. Again, most external services that are common in the data space are going to have Airflow providers. That ecosystem, again, is really strong. And because it's open source, lots of the community has contributed lots back to it. A really great place to go for discoverability for these providers is Astronomer's Registry. This is just a website that you can access. I have a link to it later, some additional resources, but that's going to be a great way to go and see, for our provider that you're looking for, what are the available modules and how do you use them? And then so putting all of these core concepts together, you're going to define a DAG in Python code, something like this. So you'll start at the top with your imports, just like you would any other Python script. You'll see I'm importing a DAG function as well as importing a couple of providers in this example. I define my DAG here. So I'm going to give it a name and some metadata like a start date, any default arguments that are going to affect the behavior of this DAG, how it runs, things like that. And then I go ahead and define my tasks. So you can see that I'm using these operators. I instantiate each one of them, and then each one will have different information that you're going to pass into it depending on what it's doing. So S3 to Snowflake operator shown here is going to require information about your S3 bucket that you're copying from, as well as your Snowflake instance. But you can see it's all mostly sort of metadata here that I'm defining. Snowflake operator, similar, I'm just going to give it a task ID, and then I'm also going to give it the SQL statement that it's going to run. So that one I'm calling in a statement from elsewhere, so I don't have to define it in this file. And then finally, I define some dependencies here at the bottom. So there are multiple ways you can do this. We'll show some other ways as we go through, but for 2 tasks, this bit ship operator here on line 29 is going to tell Airflow that the copy into table function has to come before the Snowflake op SQL string function. So pretty straightforward, not too much code. That's going to result in a DAG that looks like this. So this is the screenshot of this DAG from the Airflow UI in the graph view. You can see I have 2 tasks here. First is this S3 to Snowflake operator. Second is the Snowflake operator, and I have this dependency there. So pretty straightforward for a simple DAG. But with that base of knowledge, let's talk about some more specific use cases. So as you probably could have guessed, DAGs can get significantly more complicated than the one I just showed. We always like to show this slide as Astronomer to highlight that Airflow is designed to play well with other systems in the data ecosystem. So I've touched on that a bit already, but by leveraging the operators and providers that I mentioned before, you can implement a pipeline that orchestrates a really complicated workflow like this with all sorts of different external systems with relatively little code and manage it from all in one place, which is pretty cool. And you can really schedule almost anything with Airflow. But to show how you can actually implement some of these pipelines using Python code, I'm going to focus on 2 really common use cases within the data space. So ELT and then ML ops. And we'll start with ELT, which is a data engineer's bread and butter. So if you're not in the data engineering space, you may be more familiar with ETL or extract, transform, load. This is generally the practice of taking data from a source system, modifying it as needed for your use case, and then loading it into some destination system. So pretty straightforward. ELT is closely related, is a newer flow that has come about given the rise of data warehouses with built-in compute like Snowflake, Redshift, et cetera. So you're just swapping those last 2. So instead of doing the transformation all in Python, you're going to do it within your source system. Or I should say the destination system. So here I'm going to start with the graph of this ELT example DAG. This DAG extracts data from Salesforce, loads it into Snowflake by first staging it in S3 and copying it into a reporting table or a staging table, and then transforms the data within Snowflake by refreshing that reporting table. So you'll notice that the data is also moved over here into a data lake in S3 for long-term storage. And there are tasks throughout to kind of clean up after the process, like deleting data from the S3 landing and the Snowflake staging table. So this is a fully operational pipeline. You'll also notice that each of these boxes here represent the tasks, indicates which operator is being used below. So you can see that here, Salesforce to S3 operator, Snowflake operators. You'll notice in this example, we're heavily leveraging provider packages to use operators that are very specific to the data we're moving. Again, that's going to result in less code. So let's take a look at what that looks like. And also note here that I copied the link to the full DAG on the Astronomer registry if you want to take a look at it later. But in this code, again, first we have our imports. You can see we're importing a couple of different provider packages, the Amazon one, the Snowflake one, and then those very specific operators. Then we instantiate our DAG and define the metadata properties, again, like the start date, the schedule interval, things like that. And then we get into defining the tasks. So again, each of these specific operators is going to require different parameters, but it's almost just like a configuration. We're not implementing any of the logic ourselves. The Salesforce to S3, we just have to point it to our Salesforce instance and our S3 bucket, and it's going to take care of everything else for us. So again, kind of one of the benefits of having such a robust community is a lot of these common use cases, somebody has already written the logic for you. So you can leverage that without having to write all of the code yourself. And continuing to the rest of the DAG further down. So again, we have a few more operators. Similar story with these, we're providing connection information to connect to our third-party systems, S3 bucket information, the SQL queries that get run in the case of the Snowflake operator here. But the logic to run those queries or transfer that data is all happening behind the scenes. And then finally, down at the bottom here, we set our task dependencies. So for this DAG, since the dependencies are more complicated, we're using this chain function to simplify the code. Airflow has lots of kind of specialized functions like this, again, just to help you keep things, simple and really readable. And there are a few additional tasks in the middle of this DAG that I didn't show just because it's a little long for a slide. But you can see the whole thing is only about 86 lines. So that's pretty straightforward to implement and operationalize a pipeline that interacts with 3 different systems and runs 8 or so tasks. Cool. So now let's look at a completely different use case. So to highlight the flexibility of Airflow, for this case, we're going to implement an ML ops workflow. This DAG is an end-to-end machine learning pipeline. So we start by loading the data, we process it, engineer our features, and then train and fit our model. And you'll notice in these tasks, all of them are using a Python decorated operator. So I'll show what that actually is here in a minute. But in this case, rather than using those very specific operators from provider packages like I showed in the last DAG, we actually want full control over the code that gets run in our tasks. So we're going to write our own Python functions and then turn them into Airflow tasks. And it turns out in Airflow, this is actually just as easy. So diving into the code, again, for this one, again, I've also linked the full DAG on the Astronomer registry here. If you want to take a look and play around with it, you can also copy the code and run it yourself. But here, again, we'll start with the imports, just like any other Python script. You'll notice here that there aren't as many provider imports as we had in the last DAG. But we are importing other Python packages like pandas and NumPy to work with our data and scikit-learn to develop our model. We then instantiate our DAG just like before. Notice in this case, I'm actually using a decorator to do that, just a bit of a different style, same end result as using the function that we showed in the last DAG. And I can still define all of my metadata here. And then again, for this example, we want to have a very tailored Python function for our specific data set and model, especially with MLOps. You're not always copying an exact pattern that is the same one that everybody else is using. So this is where it's helpful to just be able to write your own Python and then easily turn that into tasks in a DAG. So in this case, for the first task here, this load data, we're simply going to define our function and then use this task decorator that you see in line 20. And that's going to tell Airflow that the function that follows needs to be a task in your DAG. So for our load data, again, we don't need a lot of code in this case. We are still using some Airflow building blocks. So in this case, we're using this BigQuery hook. Hooks are kind of like a base below operators. They tend to be an abstraction on an API. So again, rather than having to go figure out the code to connect to BigQuery's API, I can just use this built-in Airflow hook. And you see I do import it at the top here. But what I actually want to do with that data is specific to my use case. So I'm just going to put this in a Python function. So I do that there. And then moving on to, again, other tasks in the DAG. We're going to do the same thing. So the task decorator allows you to work in a functional programming style and without a lot of boilerplate or configuration code in those cases where you don't need it. So for developers who want to write their own Python functions for their tasks that get scheduled, this can often be more natural. So again, here's our fit task. In this case, we're doing some we're actually fitting the model. So again, whatever we want to do in Python to kind of work with this model, we can just define in this function and then decorate it with this task. Finally, down at the end of the DAG here, we're going to define our dependencies. And this looks a little different than the previous DAGs that I showed because we're using decorated functions here. So you can see, because we've just defined the tasks up here to actually call those functions and tell Airflow, hey, I want to turn this into a task. We have to call them here and we can set them to a variable. And then to actually indicate the dependencies between them. So in this case, this df gets assigned to our load data function. We then move on to our pre-processing and we're going to pass that data frame function in. By doing that, we're telling Airflow both that there's a dependency between those tasks. So the load data or the df has to run first. We're also telling Airflow that any data output by the def tasks needs to be available to the pre-processing tasks. So especially important when you're working with a machine learning pipeline, but this can be true in other pipelines too. You often need to pass data along kind of throughout the DAG. So this is how you do that in Airflow with these decorated functions. So it's super straightforward. You don't actually need a lot of extra code. You're just telling Airflow, hey, anything that's returned by my function, the next function is going to need access to that data. And again, with this example, so I skipped a few tasks in the middle, but you can see that the whole DAG is only about 150-ish lines of code. So that's not bad for implementing a complex, MLOps pipeline. And back to the graph view, you can see that I can now run this on a schedule. I could add other tasks to kind of do something with this model at the end. Again, I have full flexibility over kind of how this works and gets orchestrated, but the actual Python piece is pretty straightforward. Okay, so now that we know kind of what you can use Airflow for and how it works, I want to talk briefly about how to get started with Airflow. Airflow can be a little intimidating if you're working with it just using open source tools. Again, as we kind of touched on before, there's a lot going on under the hood. And in an ideal case, as a data pipeline author, somebody working in Python, you shouldn't really have to worry about a lot of that. But just getting to that point where you've got Airflow up and running can be a bit challenging. So the easiest way to get started with Airflow is actually using Astronomer's Astro CLI. So our CLI does have functionality to interact with Astronomer's platform. That's for our customers, but it is fully open source. So if you want to run Airflow just on your local computer, which is definitely how I would recommend starting if you're just looking to play around with it, you can use our CLI, and it's fully open source. So you can download it today and get started with that. The only prerequisites are that you have Docker or Hudman or some container containerization tool installed. And then obviously you'll want Python installed. You don't have to for the CLI, but to work with Airflow, you probably want that. And then once you have the CLI downloaded, it's really simple to get Airflow up and running. So you're just going to run two commands. The first is this astrocloud dev init that you see at the very top. It's going to initialize an Airflow project, which is also helpful to kind of keep things organized. It's going to automatically create all of the files that you need to run Airflow in a Dockerized setup, as well as a folder structure for adding your DAGs and things like that. So again, you can go do this yourself as well with the open source and set it up however you want. By far, the most common way of running Airflow is using Docker or Kubernetes or some sort of containerization service. If you have a Mac or Linux computer, you can just run it straight on your computer, but it's not as common. So again, using the Astro CLI just makes all of that easier. It does a lot of that for you. From there, once you've started that project, to actually get Airflow up and running, you just run astro dev start. It's a little hard to see, but that's here on like the 5th line. And that's going to use Docker Compose under the hood, and it's going to spin up a couple of containers, again, for you to run Airflow on your computer using Docker or whatever other supported container software that you're using. And you can see in my terminal printout as it goes down here at the bottom that that's going to spin up 3 containers that are corresponding to those core Airflow components that we talked about earlier. So the web server, the scheduler, and the database. So in this case, we're using Postgres. Postgres is the most common. There are a couple of other supported ones that you can use for your database, but almost everybody uses Postgres. So again, once you have that spun up, you'll be able to, add DAGs into that project, again, just as Python files. You'll be able to see them in the UI, so you'll access a local host and through the Airflow UI that way. So again, super easy to set up. Other resources I want to talk about, once you have Airflow up and running, you can start playing around with it. And because this is a short talk, you can really only scratch the surface of what you can actually do with Airflow. Obviously, data pipelines are complicated. The ecosystem is complicated. Airflow has a ton of functionality that I didn't get to touch on your specific tools. But if you're brand new and you want to just get started playing around with it, a couple extra resources that are really great ways to get started. And I sort of have curated these from, years of my current role at Astronomer, where I do a lot of Airflow trainings, as well as having learned Airflow myself. So a great place to get started is Airflow Fundamentals Certification. So this is going to have a whole course that goes into the things I touched on, plus a lot more, but in a lot more depth. It is a great way to get started. If you want to, at the end, you can take a fun test, and it's a nice thing whenever you get certification, I guess, but you don't have to. You can just use the course as a way of learning, but that'll have sort of interactive modules that you can go through and actually practice sort of creating DAGs if you want more sort of a structured learning environment. And then I've also added some additional resources here, including links to the Astronomer CLI and registry that I mentioned earlier throughout the talk, as well as some additional written and video content resources for getting started with Airflow. Airflow can have kind of a steep learning curve. We tend to say, if you already know Python, you're in really good shape. Actually writing those DAGs is pretty straightforward, but getting from beginner to more proficient level can be a big jump. So we've invested a lot of time in kind of creating some resources for the community to make that journey easier. So these are some that could be really helpful here. But with that, while we have a few more minutes, I know this is a topic that frequently generates a lot of questions. So I'll go ahead and open it up and answer anything that anybody wants to talk more about.